Buckeye Engineering Design Showcase. I'm Bob Rhodes. I'm the Director of the Multidisciplinary Design Capstone Program at the Department of Engineering and Education and the College of Engineering. I want to first off thank a lot of the organizing committee for this showcase. Dr. Kadri Harris has also been very vital from the standpoint of the Engineering Foundations courses and getting this design showcase off. But let's just give them a round of applause. I'm not going to go through all the showcase team names, but let's just give them a round of applause. I also have the distinct pleasure of introducing our Dean of our College of Engineering, Dean Howard. I would like to say thank you for all of your support for this showcase and supporting all of you as students throughout your engineering career, academic career here at Ohio State. So, Dean Howard.
First ever Buckeye Engineering Design Showcase. And why is that important? You represent what is possible. Why I love this is we have on one side of the room, we have our graduating, maybe? Yes! And on the other side, we have our first year engineering programs. And so think about this. This is the bookends. They're louder. You still have 3-4 years. First year engineering. So one of the things why this is so impressive is that as engineering on both sides, when you come into the Buckeye Nation, one of the things as an engineer a lot of times, you don't necessarily know what engineering is. You're going to classes, you're taking your math, you're taking the physics, and what we try to do in this first year is actually have you take some of that application and figure out what it is. By the time you're doing capstone design, you guys have it. You guys know what it means to stay up all night. You guys know what it means when it doesn't work the first time, how quickly you need to pivot. Whereas first year, you kind of work it out. How many of you stayed up last night making sure you finished this? Wow, you guys are better than I am. So one of the things about engineering is it really is a practice. It is an application. It is thinking about how you take your engineering know-how and apply it to things that are important, problems of consequence. And why I love this is that this is the bookend, and we're going to continue doing this so that you, as the seniors, as having navigated the field, whatever the discipline is, you have the first years seeing what it's like. Seeing and saying, oh, there is a 4-year after, there is a 5-year after, I will be there one day. And what we ask of you is that as you see the first years, you come back and you participate, and you actually share what it's like. Because a lot of times when you're coming in the first year, you haven't taken your discipline-specific classes yet, you still don't know. But you guys know. You guys know what it means. You know what it is to be an engineer, because you are graduating, you are going out, and you've navigated where they are now. And so why this marquee event is so important, it is the bookends of experiential learning. It is the bookends of trying to figure out and navigating, and having colleagues and having friends. And so it's why we are so excited that we have this marquee event to really showcase what it is. So I want to say thank you. I know for first years, it has been an experience. And I know for our capstone, it has been an experience. But it's one of the lovely things. And for those of you that I will see in 2 weeks, congratulations. And for those of you that I will see in the fall, congratulations. Thank you, and enjoy OH!
Okay, so let the games begin. Capstone students, at your stations over here. First year students, good luck on your robot. That's the wrong question. Oh, all right. I tried to tell him.
That's good to keep it clean and prevent smoke. Right? And then we have a user interface here that's not hooked up right now, but you can follow different host curves based on how tall or like how high your beams are grown, like altitude, and how dark you want to grow. So that's pretty much how it works.
Something you could have like in your house? Yep.
Yeah.
Like, so it says hobby, so it's like that.
The idea here is that we made this 18 inches tall that it fit between like the top of the good. So you can push it up like that. I'm just doing fine. Why do we need this device? So look at if you look at this picture right here, you might not be able to see it. That's not where it goes, but we have a list of all the different posters on the market. Right? As long as you bring some high-end features down to a lower price. Right? So you look at some of these that are over $2,000, those are the only ones where you're going to save and create your own version profiles, which is what I was talking about with the different media outfits. We were able to bring that down to something that costs under $600. So we wanted to bring a lot of that into something that was more affordable. That's a good idea. Some coffee beans, we roasted these.
Send it to me, and I'll get that up on the list.
F6, G7, H1, and E4. Please report to the courses.
When we started, we were just
F6, G7, H1, and E4. Please report to the courses.
That as well as these are really like integrating a storage with a display. So like most people either like store their cards in like a binder and it's just like closed, and they just have to flip through it. Yeah, so they just have to
Turn that on so it's color.
they just have to put cards on a shelf, and they just sit there. So this has storage in the back, and then a display up front, and it will actually go select cards out of the storage, and place the cards in the box, so it's like automatically cycles through the collection.
Robot that swims next to you.
Oh,
And you can tell how fast you want to go, and then you can follow them.
that's where that facing comes in.
Take this
Okay.
card out, put it in the storage, just grab it in the
What's the
Okay.
display different?
Just all the storage locations with the array, so the locations with the array, and then the coding would be able to match or certain cards to certain storage locations and index everything, so it knows where the cards are at, it knows which cards to grab and when it wants to grab them.
Because like, were you looking at actually implement the school business?
Yeah, so yes, yeah. I mean, you want to say it? Yeah. Okay. So we only have it set up for one card right now because it is so pretty finicky and makes errors here.
Because otherwise it would be too much.
Yeah, and like,
So you're able to find 2,000 instead.
yeah. So all of these are 3D printed. I did manually sand it to like the different. Yeah. So yeah. So like, there's little chambers that are sanded, and each one's like sanded a little differently. So each one behaves a little differently. With more time for like professional manufacturing and stuff like that, it would behave a lot more consistently. But so inside, this is a 3D printer features that we got from a kit and built, and then we designed our own tooling to actually play with all the cards and stuff.
I go there for like a bar.
Yeah, you can look inside. It's not panels. So the card back into pixels wouldn't have as much trouble because each top loader actually bends, so like it's grab. That was nice, yeah.
Do one more. Try to.
Welcome to the first round of round one. A2, C9, B6, B8, intermediate law course. 1. F6, G7, H1, E4, course 2. F6, G7, H1, E4, course 2. A2, C9, D6, B8, unqualified. Round match 1A and 2A.
I went into correct my school.
Yeah, we're talking about doing it. So after I come done grocery shopping, this will probably be wrapped up. And then Alright, see ya. Maddie's group, you know how like there's the recycling and stuff like that, when you go to like that.
This is our lever, but in the lab, they use their levers.
Yeah, and so you can look into the I'm health science. I'm an engineer.
This is based on the way the writing.
I said we're more than happy to like read more.
Really looking out.
And then it just kind of, as TCP goes down, the amount of HA goes up. And the second shortest one was one of post HA. So we still kind of are thinking like HA does ultimately add like increase the stress that it can take. But we still need to do a lot more testing. And our sample size was super small to the point where it's like, we don't even know if our data is going to test like 7 or 12. You know what? A lot of BTC is used in dental applications actually. So they like using it for like teeth treatment, things like that. Like fillings, even like teeth replacements they use it for. Bone regrowth. They use BTC in bone regrowth throughout the body as well. So they know that it is biocompatible, which is why they want us to test the mechanical strength. That's what they're really focused on, because the knee undergoes a lot of mechanical forces as you're walking, sitting, things like that. So they want to make sure that it's feasible to put in there.
Are they using anything right now for the like knee replacement?
So right now, this is trying to replace polymeric material, so plastics, which is stronger in nature but less biocompatible. So a lot of the problems are foreign body responses, and a big thing with two-stage exchange arthroplasties is you want to be able to diffuse medication slowly over time to kill infection. And plastic material isn't good at being very porous, so it kind of just releases the medication all at once instead of slow, controlled medical release. So they're hoping that this material not only will be more biocompatible, but will also be more porous and controllable when treating infection. That's the next step.
I remember hearing about this project. It seems so like crazy from my perspective to like just get this as your like first project experience. You know what I mean?
It was very just jump into it, do the research and try. I'm actually really blessed that we got results. I think it's pretty cool that we were able to put something together. Even though we only had 8 pellets or 7 pellets that we were able to test. We still got something, and that's good. Yeah, we actually had an idea. Because a lot of first semester was just spent doing research, and we didn't even have like the legal stuff signed at that point. So now we have everything signed, we're gonna have like all next year to just like test ratios, try to actually create the space that like shape itself, and then work on it.
And just to like figure out like what all these machines do, I feel like
It's just
like a crazy learning.
Yeah, it was a good time. Cool. Thank you.
See ya.
We started identifying
D7, D is in boy 7, A4, D4, D8, D is in dog, C2, C is in chocolate, 2, D7, A4, D8, C2, D is in dog.
But you're good now.
You guys want to try it? Go ahead.
I want to walk around and look at stuff. That's okay.
The point of this argument is like if you press over here, you can have projects
It's like just for I guess it's
Right? Hey, Marcy.
I guess they're always wrong. No, I love her. She's so awesome. It's actually such a film. I mean, I can just show you mine if you want to see it. It's not very exciting. I had to
Oh, wait, was it like a achievement?
No, I think that's single.
Oh, right. I was thinking of the second.
Yeah, I might take this out. I'm just looking at
So now, you have 8 pellets in here. But it's situated.
No one wants to read.
I have no idea what one right now. So I'm guilty of last week's, but I'm sure it's helping.
F1, G1, E6. H6,
But it's weird because like the other
F1, that's fantastic. G1, E6. Everything brilliant. Please move to the course. You'll be up next to Match
Dude, that's a whole need a server running.
Yeah, we can about 5 minutes up because it's not that's because it's inside a little bit.
I'd say the most like run into a wall or fail diagnosed
The following teams, please report to the course. A5, B3, 11, 4. A is an apple, 5. D as in dog, 3. C is in Charlie, 1. B is in Batman. Please report to the course. We'll be up next on match 9A.
Maximize the yield and movement autonomic motion, which comes into play with our sensor, which is a time of flight, 9-axis, and a small chip on it, in real time. And I visit our software.
The following teams will report the course. H3, C3, and D5. H3, H course.
Basically, it's from
C is in D5, there's a don't relate 5. H3, C3, D5, please report to the course.
That's what I say is most innovative is our movement system because it uses the PFL, and on top of that, it also has a motion profile to enable maximum acceleration of our robot. Because if we just run all of our motors at the full 12 volts, it will actually tip over and get very unstable, and that will mess up the tracking of our sensor. So we use a motion profile and a PDFL controller combined to achieve maximum speed.
Aspect for component of your robot, those integrations to get
With the following teams, please report to the course.
We were lucky that most of us were falling into place. We did the biggest iteration with our farm, and that's mostly with respect to completing the glucose bin task. Our robot was designed to minimize actuators and keep it simple, and so we thought that we could use the bottom of our claw covered in a high-friction material to just spin the top of the compost bin. In reality, there was too much unreliability between different courses that didn't work effectively, so we had to pivot. So we tried a few different ideas, like side sticks to spin it like multiple different robot motions, and ended up settling on this very simple servo-driven design that we tried away from at first because we wanted to avoid potential unreliability. These servos are so small and have plastic wheels that are so fragile that they could break later on. Like for example, our main servo is, and that's why we wanted to use one main servo, is because if we could buy one nice Metal Gear servo that was very over-spec, not to worry about it breaking. But we did end up at the very end, I decided to just try this out because just due to like shipping times and other items, it was kind of our own option.
So what kind of use cases are you using sensors to help navigate the course? I know you started talking about it.
Yeah, I can go a little bit. So basically the way our robot works is it's just a massive switch statement for every single task we're completing, and then we have asynchronously running a constant control loop on our position, and we have because of that we can enable and disable just one axis of the control loop, so that we can like, let's say we want to move to like line up with a wall, we can use just like a force or a power command in that axis, but still keep our heading and other axes aligned. So that's always running in asynchronously, and then within our switch statement, all we have to do is just set target positions. So we just have a massive list in our code of just every position we need to go to in the course. And so we just set those positions to the drive command, and it just goes there. And then it has multiple functions to tell us information about the robot's velocity, which we use sometimes on like high accuracy movements. We'll make sure we have a velocity and positional tolerance. Or we have high position tolerance commands where we need to get like roughly in an area, but we don't want to like wait to get all the way there. We do that to kind of maximize our speed and not waste time waiting around. And we also have safety checks and timeouts. So if any motion takes then it automatically just ends the motion to the next task. And that way, even if we might fail that task, we can get position in time, but we still complete every other task and get it stalled out.
What coding strategies did you implement that kind of set you apart from other robots or robot designs?
I mean, like I mentioned, our like big case statement system. I think the biggest difference is that all of our code is running continuously in parallel. So every loop, we do a sensor update for all of our sensors, like velocity, position, anything else we need to update. And then we also do like a logic check, which is like separated from that, where we check are we at position to go to the next task. And that's been the biggest advantage because in our code, if we want to add a new task, we literally just add to the end of our switch statement more case statements, and it won't affect any code prior to it. And it also makes it easy for testing if we want to like remove the middle section of our task. We just tell it to skip those statements and go to the one way after it. So that's really allowed us to test quickly and iterate our code fast and not have like small little like bugs, because everything is very clear and written out in a sort of a deterministic manner, where if we see an issue on the field, it's very easy to trace what exact line of code caused that issue. It's not convoluted, there's not many steps of abstraction.
To the following teams, please report to the course. H5, E2, and G8. H is a horse, E is an elephant, G is in giraffe, H5, E2, G8. You'll be up next on Match 12A.
What the issues we face in this was okay,
I don't know what's wrong today.
maybe it's just sit down. Actually, my feet is today.
With the following team,
Yeah.
C2, D3, A2, H1. C2, D3, A2, and H1. You'll be up next on match 1B of round 2 of round 1. C2.
So I guess square on two walls is kind of like given, I guess, but the PID, are you familiar with PID stuff? So for our forward function, we use PID. I guess there's other than that, I guess they just put a lot of time into like this whole stuff. I've not really done a lot of code in the past, so I kind of like PID. And I guess the only notable thing is that for the straight function, we just use the PD. Not just
Or we can do it.
50% baseline. Now it's like a 10-second test. So that's like, we kind of made it the hardest scenario possible on ourselves because usually it takes 90 seconds to make the new one the back to do. So we were saying, can we do this in 10 seconds? At least in 10 seconds. So I think that would actually be higher. Exactly. Yeah, because they're on a strict surgery, so they're running these surgeries like every hour, so they can't get behind. So it's exactly.
I'm actually curious if it's like that.
We're like, oh yeah. I saw it in the bike wheel thing. Yeah. Yeah. Really?
Hey, how's it going?
Yep, are we ready?
Yeah.
Okay. Let's start in the south.
Okay.
All right. I'll be back someday.
Okay.
If I go, listen.
When is the I don't know how I can send it.
I took her around to.
I saw that she was brown. I wasn't sure if I caught it before or after. I was running around and talking to you.
Yeah.
All right. Okay, well,
He caught it on.
Yeah,
nice.
I got it.
Excellent. Okay.
All right. Actually, you're not going to capture me.
Okay.
Let's just go to the south, too.
F4, D1, E4, and C1. F is a fantastic 4. D is a dynamic 1. E is a
Zero or this is
C is not sure what it is. F4, D1, E1 is next on next 3D.
Yeah, I got to head south then. Oh, I'm just
It's a bummer the microphones didn't work with this iPad. It worked with the other one.
Oh, it did?
Yeah, but it didn't work with this one, so I'm asking people to speak up. So they could.
Telling me that you must be watching the live stream. And she said something like, "Oh shit, you getting nice workout done?" What she said? I just logged on. Well, you have the image black.
Yeah, yeah.
She could hear.
Shouldn't be able to. many groups are in here? I see. Livestream on YouTube. Chemical by molecular project of Capstone. Introduce yourselves with your ages. Okay.
Just go down the line. Start by introducing yourself.
I'm Caitlin Cookett.
Matthew Gray.
I'm Cheyenne Holtush, and we're all chemical engineers. So the project we've been working on this semester is a sickle cell crisis detection device. So basically, patients who have sickle cell disease, they experience these very painful crises, which ultimately result in hospitalization and require opioids to help deal with the pain. However, right now there's not really a way to deal with or to test if someone's actually experiencing a crisis or just disease-related pain. So what happens right now is people are getting assessed just on a pain scale, which is different from person to person. So not a super great test in place. But the Chalmers lab has came up with a sickle cell disease crisis detection device that ultimately will allow people to test if they're experiencing a crisis. So what our Capstone project has been working on is taking this research device and then ultimately commercializing it. So we've been working on creating a cartridge that can be inserted into the device, and it's disposable. So at the end of each use, you would just get a new cartridge. So we've been kind of playing with that design, and our hope is by commercializing this device, patients will be able to get the care they need quicker. It'll get rid of some of the stigma associated with patients who have the disease, and then patients will be able to live a happier life.
So to break it up into 3 different sections for our project, we want to really look into our regulatory, our economic, and our device design. So starting off with our design constraints, we saw that we had run into 3 different issues. Here we have a depiction of our CTV, the cell tracking velocimeter. This is a device that's already established, but now we're trying to apply actually having a disposable cartridge. So making it to where it can be a single use, but also a point of care use actually. Right now it's at lab scale, so we're having other implementations that won't be really able to be applied at care. And we have 2 different design criteria that we need to look into. It is being able to dilute our sample and also having an anti-aging. So that's one of our design constraints, is making sure that we can dilute our sample to 1/1000. And lastly, we want the cartridge to be disposable and reduce any risk of contamination from patient to device. Moving on, we have our device design right over here. Basically, we have the blood sample being taken through capillary action, which will be filled up here. We have a scale and gas loop, so when we do go to insert the blood sample into our actual device, it won't be able to go in or out. It will just be directly encapsulated over here. Also, we have our dilute sample in this area and our anti-collagen agent in both regions. From there, then we can push down on our plunger to then be able to attach to our cell tracking velocimeter. Running into this, we should be also look into our regulatory research. This project does not have anything that is FDA approved now, so we do need to look into how we can get that going. So our device does fall under the 21 CFR that is
device that would be able to use in both clinical and at-home healthcare settings for the detection of a sickle cell disease crisis. Based on the work that's already been done by the Chalmers lab, we think that our device design could be actually implemented in the next 5 to 10 years, ideally. But we think that we made decent progress towards discovering some of the regulatory and other design constraints that are currently being faced by the group, and that the device shows promising conclusions for the treatment of sickle cell disease crises. Thank you.
Are they in the right spot? Yeah. Oh, is this for the live? This is Livestream. Oh, wow. So please introduce yourselves with your majors and just talk about your project. Please speak up. You got it. You got it.
Hi, hello. My name is Justine Bree, and I'm a biological engineering student. My name is Lisa Briggs, and I'm also a biological engineering student. So our project is an irrigation analysis of a farm in Ghana. So to start off, when we came into the fall, we established all of our existing conditions based on what we knew. Because our sponsor actually lives in the Netherlands, and our project is based in Ghana, and we're here in the States, communication was a very large aspect of this project. So when we came in, you
score of 100 is the best that the robots can do. At this time, we are prepared to begin the head-to-head competition. Give me about a minute, and I'll call the first robots to report. Thank you very much.
Go, Casper.
Would the following teams please report to the course? D1, B8, H8. You're up first on round North 1A. D1, B8, H8. You're up on North 1A. Would the following teams please report to the course? D6, B4, C4. You're up first in round North 1B. D6, B4, C4. Please report to the course.
Looks like I got assigned a bye for this one, so could leave early.
Yeah, no problem.
So.
B4, please report to the course. You are needed on course 2 immediately. Team B4, B as in boy, 4 as in 4. Please report to the course.
The rest of them aren't real ones. Can I go film the pictures of them? I mean, you can. Alright.
Would the following teams please report to the course? H6, G8, D9, H6, G8, D9. You'll be up next for round North 1C. Would the following teams please report to the course? H1, D2, C7. H1, D2, C7. You'll be up next on round North 1D.
Yes, the heating hide has been blown for. Yeah, I can just.
back over there.
Because it's only 2 people allowed. You're so blind. You're so blind. Alright, I think we're going on A here too. You see where these guys are sitting? You can see the camera. Well, you didn't know, so. D9, yeah, D9. We're, those two, because they only let 2 people from group go. So, like, I'm over here. Guy went last round, so we're just swapping. Go on. Nah, they're over there. You see the guy in the dark blue shirt and the chokri? Those 2 are my group. Where's the 3rd guy? I don't know where he is. He's probably sitting over there somewhere. Are they at 100? That's our goal. We've gone 100 before, once. Huh? I got 100. Only me, not my group, only me.
It was hanging over the edge of the table. It was going to drop.
Yeah, so. We're at A, right? We're at A, right?
Congratulations, D6.
I'll watch from the camera, because he's on the other side, I think. Is it? Oh, do not redeem. Look, everyone on our team's Indian. How'd you guys do? Did you guys pack, like, advance? That's all happened.
H1, D2, C7, H6, G8, D9, H1, D2, C7. Please report to the course immediately.
Where's our team? Where'd they go? Oh, they're talking. The kids are talking.
Yeah, you're good.
Huh? Nah, I won't do a few. Maybe I'll see. Which one's D? Which one is it? I don't think my... I'll play
Welcome in, everyone. My name is Ellie Taneva, and I'm a 4th-year mechanical engineering undergraduate student, and I'm also the construction lead for the robot course program at Ohio State. So, as you've already gotten a little bit of an introduction to the robot course, it is fully built by TAs, and students have 1 semester to build, design, and program a fully autonomous robot that can navigate it and complete as many tasks as possible in the 2-minute time allotment. So right now we're watching the head-to-head competition in the screen behind me, and we're going to watch 4 teams compete in a single elimination bracket, so the only team that wins will move forward and everyone else will be eliminated. I will be here to narrate to see how the teams are doing, but we have teams H6, G8, D9, and then a bye. So only 3 teams are currently competing. And again, as I said, only 1 team will move on to the next round. So starting out, D9 on the top right corner is currently at 30 points, followed by H6 at 24 and G8 at 14. The robots can complete the tasks in any order they wish, besides starting at the light and hitting the final button at the end. So that's why you're seeing a lot of different strategies going on. seems like there's some issues with Team D9, but unfortunately the team cannot touch their boat once the competition starts. Update on the results. H6 is currently at 44 and G8 is at 32 points. We're about halfway. It appears that D9 might be stationary. For this round, this was quite exciting. We have a 1 point difference between H6 who got 44 and G8 who got 43. But unfortunately, only one person can move forward to the next round, which is going to be H6 Buckeye today.
Congratulations, H6. You're the winner of round 1C. Moving into the round of Sweet 16, H6.
Gonna do a very quick little interview.
Major.
So now we have the team that just won the round we watched, who is H6. We have 2 out of the 4 members of the team present today, so you guys want to introduce yourself real quick?
Yeah, I'm Evan Sanborn. I'm a freshman student, and I'm majoring in computer engineering.
I'm Ben Fraser, and I'm majoring in biomedical engineering.
Alright, so what did you think today during the first round elimination? How did it go? Was it stressful? I saw you won by 1 point.
Yeah, I mean, we were just kind of hoping that the other team would stop and not be able to do the task since our robot messed up.
What did you guys mess up? What did you plan?
Our gear hit the side of the window.
I see.
He ended up getting stopped.
Gotcha. Okay. Well, looking forward to the rest of the competitions from you guys. Thanks for coming for a little live stream here. But go ahead and prepare for the next round.
Yeah, thank you.
Now we're going to take it a little bit of a different route. We're going to talk to the TAs who are responsible for building this course for this year and last year. So, would you guys like to introduce yourselves?
Hi, I'm Olivia. I'm a GTA for first year engineering. Go Robot. Hi, I'm Alex. I'm a UTA.
Hi, I'm Tia. I'm also a UTA.
I'm Shivam. I'm also a UTA. Hi, I'm Raghav. I'm also a UTA.
Raghav here is one of the construction leads together with me. And we set up this course over the last 2 years, and we're currently working on another brand new course coming up in next year. Excited for that?
I'm so excited.
Okay.
Show the course here.
And as you can see, this is a close look of the robot course. This is just one section and a TA right next to each section. A bit of an update on the outline and the aesthetics of the course. We have the starting button in the bottom garden. We have the compost, the apple bucket, which robots are supposed to pick up. We have the window on the top, which is the greenhouse portion. Next to it, you can see the flowers, which are an aesthetic component of the course. Next to which is the humidifier button, which students are supposed to read colored light in order to identify which button they're supposed to hit. Going forward, we see the levers, which are supposed to be for different fertilizers. And then to the right is the drop-off location for the apple basket. So as you can see, overall, there's a large team of sustainability built into the course, which is a big core principle of the EED that we try to maintain. set at the robot pit, where every single student team is positioned with their robot and all of their supplies in case anything needs to be changed in the robot. We have one of our teams here, H1. I'm personally their TA in 1282, and they won the in-class competition last Friday. So would you guys like to introduce yourself?
I'm Michael Manley. I'm the first year Capstone engineer.
Congratulations, E4 Betsy against all odds. You are the winner of round East 1A.
I'm B. Sprinkle Perez. I'm a
E4, the winner of round East 1A.
Thank you. So how is it going today? You haven't had your first round yet?
We just did.
You passed?
We got 100.
Nice. Good job. Okay, how are you feeling? Anything I should look out for while you guys are up
E4,
there?
congratulations. We're just going to be consistent. We're just going to keep doing those 100. Moving into the round of 16.
Doing our thing.
Yeah, this team has been really good at keeping things consistent. They got consistent 96 out of 100 during the in-class competition, and it seems like they're starting to get consistent 100s, which is a full score you can get. Any challenges during this semester-long project that you guys want to warn future project teams about?
Save some, reserve money in case something breaks.
Especially the servos, if you can, I would recommend getting a servo not from the engineering education shop. If you can afford it, get one with metal gears, not plastic, because they are very prone to shrimping and breaking.
So overall, what did you learn throughout the semester working on this project in terms of engineering?
You're up next on South 1B.
I was going to honestly talk about like in terms of teamwork because I feel like that's
sure. Yeah, you can talk about that.
Okay, perfect. I think this is a really good opportunity to learn great teamwork skills. I mean, you have to learn how to manage yourselves as a group, and there's a lot that you have to do for the project. So as a group, you got to keep yourselves like on time, communicate effectively, and it's a lot of fun too.
We also had to learn how to be really resourceful because we spent a lot of money getting a good base with the 3 motors to start, so it didn't leave us with a lot of extra money. So learning how to work with what we had was a big learning curve.
I feel like another big thing too is also just being able to connect the skills, especially that we learned in FEH1. So we did a lot of soldering, we did a lot of technical writing as well. So writing those final reports was definitely taking a lot of skills that we previously learned from FEH1. And then I would say the biggest thing that I learned in terms of engineering was probably just being creative and trying things and keep trying and trying and trying and trying. And I think that spirit of not giving up is really, really important.
I'd also say that, like in terms of testing, we always thought that we needed like a day or 2 to test, but in reality we needed like 3 or 4 to test. And so, like kind of in like the early stages when we were starting to like do the milestones, we were frequently kind of like running around on Thursday to try and do everything. And so, just like dedicate more time to testing in the future.
Good advice. Well, thank you so much, guys. Good luck today. You're going to do great. We're going to be watching you and rooting for you. Sounds good. All right. Sign up. What is up next? Given to first-year engineering student. As you can tell, this is a very special and unique program containing many honors engineering students that are very passionate about this course and will go on to be great engineers. My name is Ellie Teneva, and it was a pleasure being your host today. You're now going to be moved forward to another first-year engineering project, a nano and AEF project. So enjoy checking that out. I'll see you later. teach kids algebra, elementary level algebra, and middle school algebra. Sorry.
I brought it just in case.
So, the premise of our game is we wanted kids to get better at algebra. I wish I had algebra. Algebra game as a kid growing up, I just play.
I said he was a wise claw because he's like huge. I was like, if I just said like claw.
That's how it works. Like, he knows algebra. Like, I don't want to say no, I want to talk to someone like, you know. Well, I get to see that actually. So when you were selecting a certain structure, yeah, and then we have like, yeah, I thought we also can't put together. I noticed that. Yeah, so this scene is like a top-down perspective. Yeah. Once you click over
Like a side view?
yeah, like a side view. So we gotta get close to that.
Yeah, I didn't want it to be where you could just like stand at the entrance. Yeah.
You can like do it right.
It's like a mixture of like online resources. Mine, so I mostly designed the forest biome. Most of that I made myself, just because a lot of it was very specific. I couldn't really find like resources for it. But once you get to Eileen's biomes, you see we kind of start using more of those tech sheets.
Yeah, because then we're like literally like a full background when you need a background on the platform. Yeah, now it's really fun. The Minecraft story at the beginning. Yeah, we got. Essentially for the elemental things, yeah, like, you know, they get really confident and they can go and do something. So now you just put the structure of the melt and start moving around and it has like your gravity like jumping.
And me and you were really showing off the haircuts to the camera.
Oh my god, why am I that close?
Did you not know that camera was there?
No, I didn't know.
They told me.
Oh my god, my hair. Wait, Dr. H telling me it's like, oh my god, it keeps going back and forth. So yeah, so a judge actually was like, oh wait, can I jump over the camera? I'm like, yeah. So, well, as you progress, it's harder and harder when you're getting on it. What do you do? You're just able to finish the stats it out. Tell me about the what is it? So it's Walker, he can explain his course time, how he kind of did all the walking and stuff, because that was also pretty difficult.
They're very similar, but she had to like compensate for like, you know, the side perspective.
Yeah.
But I'll let her describe like what she did.
For the jumping system, it's like
Will. I am a TA for 1182, and I would love to show you around some of the projects that our wonderful students have made so far. So, if you would be willing to come this way. I'd like to show you the reminder teddy by one of my student groups. Actually, they did a wonderful job. And if you'd like to introduce yourself, go to your pitch, please speak up as well.
I'm Trey Hiley. We're with Group M. We're going to go through our pitch here. So, we were targeting parents with kids from ages 5 to 10 to try to get them to allocate time to give it to their kid. You don't want to be in the kid. So, we're trying to allocate the time to get their kids to take the stress off of the parents. I'll run you through the demonstration right now. So, if you want to get your, I don't know if you can screen see it mine. So, you can select mode, which will allow you to change the light and the sound system on there. We'll leave it at burst, but there's a bunch of different ones that go. Urgent. We'll go through there. Yeah. And then we'll go to our tasks, which there are predetermined tasks in there that you can go through. Clean up, bedtime, wake up, and homework. Select homework. And then you go to start.
What the hell?
You don't like it? And then it'll go to a timer, and then once it reaches 0, it'll light up, and then a sound will go off.
The sound isn't clear, but the light is clear.
Wow, a wonderful job. I'm actually really proud of them. Moving on, we have a really cool other project. If you want as you can see, a lot of judges are here, so they started judging when we planned to produce. So sorry for this miscommunication. Go to would you like to explain your product? Can you introduce yourself? Please speak up, explain your product. And
alright, so we are Team H, that is Barrett Ward, Sam Gold,
Kyla Hager, Alicia Bright.
This is our project, Aquanurse. So it is a 2-in-1 integrated chicken feeder and watering system. Right here you have a stainless steel water bottle. Can I do that? Are you able to actually get that? Alright, stainless steel water bottle with a drip feed valve on it. So that gets the water to this side. And then you have a slant in here, and that gets your feed down to this side.
So right now our target users are small-scale farmers who don't really have enough time for daily commitments, and because they have 9 to 5 jobs and they have other priorities. Just in winters, traditional chicken waterers they tend to freeze, and breaking the ice around them takes 10 to 20 minutes multiple times per day. So our product is an integrated feed and watering system which minimizes that freeze risk, and it saves around 30 to 40 labor hours every single winter, and that equates around $600 saved every single winter, and that addresses the massive $10 to $11 billion growing market in poultry feed.
So, in comparison to our competitors who are just a feeding or just a watering system, ours is integrated, and each one separately costs around $80 to $100. And so our prototype itself costs about $20. So even if you include labor and profit and revenue into it, it would all be cheaper than just buying 2 separate watering feeding systems.
So we started our design by first interviewing users, and by the user needs, our main user needs were accessibility, sanitation, and just durability. So for accessibility, you can see our product, you can take it apart, put it back together in under a minute, and it's also easy to clean with the acrylic marks. And this brings up the value of the product. You're getting more healthier chickens as no contamination, cross-contaminations are very limited with this. And you're also saving time as a small-scale farming. You're saving time, and you can do a not worry about having to keep feeding.
That was wonderful. That was great. Thank you guys so much. Moving on to this group over here. Could you introduce yourselves and then talk about your thing? Please be loud.
Yes, I'm Connor Wolf. I'm Matthew Reed. And I'm Jimmy Schneider. We have another teammate, Carter, who's not here right now, Lindsay. But I guess the first thing is, if any of you have ever played a musical instrument before, this product was meant for you. So, as you can see here, we have the traditional music stand used actually in our bands now. But one tiny push, sheet music can be gone. And then in marching bands, is something called a lyre that people use, so they can walk around.
Yeah. So this can sometimes clip onto an instrument, but the problem with this, it obstructs your vision. A lot of them are flimsy, it horns down. They can fly around everywhere. Also, not every instrument has this holder. So our idea with this was that we can get rid of the music stands altogether and just beam it right into this OLED screen right here. All of the sheet music is compressed onto here. It projects onto this mirror and then right into the eyes.
We could try to show the camera the best we can. I don't know.
We're just going to cut the music stand out of the equation entirely.
I'm not sure if
I'm not sure if how it looks, if you can see it through there.
But the mirror,
nice. So, yeah. So that's like the main idea with that. We're looking at marketing this towards like performing ensembles, like directors who could buy it for the entire band. Because there's like a great market for this. This is the only kind of product this is the only product of its kind. And it only costs like $35 for this prototype. So it's a really great investment.
And the idea is this can even fit to like our final concept is going to hopefully fit to any pair of glasses. This is only 2 parts, so it can come apart. This is just a test frame to kind of show the proof of concept. So it should be adjustable, and it doesn't affect your vision if you have a pair of glasses already.
That was wonderful. That's amazing. Really impressive. Thank you guys so much.
Yeah, thank you.
Moving on, we have some cool other projects as well, and then we'll switch over to 1282. Walk with us through the Huntington Club. My first time being here. Probably a lot of people. I'd like to show you the Helping Hand. This is a very cool project, and if you'd like to introduce yourself, introduce your project, what's your finish, that'd be great. And please be loud.
I'm Sophia Bird. This is the Helping Hand. It's an extendable hand pickup tool for people with mobility-related disabilities, like wheelchair users and arthritis patients. And it is Arduino and Atlas. The idea is that the claws open and then we'll pick up objects. And it's extendable.
Pretty cool. I think so. But we have one more for 1182, and then we'll move on to the 12. Would you go live stream real quick?
Yeah.
Just introduce yourself, go through your product, and yeah, what's your pitch? Thank you. And be loud.
Hi. I'll go first. Hi, my name is Cameron. Hi, my name is Ed Schumann, and we're Team C, and our product is the dual washer. It washes both clothes and dishes.
So here we have our motor that kind of spins in the back that kind of creates like the wash cycle here. And this is our code for the washer.
And here's the design for the 3D model. We designed it using Onshape, and then we 3D printed it, as you can see here. And yeah, here's some of the dimensions for it. That's cool. Is there anything you want to see in particular?
Use cases specifically. Yeah. I'm assuming small apartments or your.
Yeah. So our target audience and our use case would be for young working professionals who might live in a smaller apartment, like a studio apartment, or who are generally limited in space. So this machine combines the functionality of two full-size dishwashers and clothes washers and puts it into a size format that is space efficient and saves space for the user.
Thank you guys so much.
Of course.
All right, I think we'll move on to our next host. If you'd like to introduce yourself.
Hey guys, my name is Sush Kapala. I'm a third year studying electrical and computer engineering. Within the EED, I serve as one of the lead UTAs for the 1280 first year engineering courses. And I'm going to take you guys down over to the 1282.02 projects. So let's head on over. 1282 is fairly similar to the 1182 courses that we have. What's different is the scope. So we have two categories that our projects will choose from, either nanotechnology or sustainability. Nanotechnology will implement the use of nanotechnology to improve the medical procedure, just making it more effective, while the sustainability groups will either improve the efficiency of an existing sustainability measure or just to take a regular common task to make it more environmentally friendly. So if you follow me, we're just going to take a quick turn after these. And we'll go interview some folks who are done with their judges. Would you guys like to be on the live stream? So this after that, are you guys able to be on the live stream? Yeah! So if you guys want to introduce yourself, talk about the solution that you guys came up with, and then I'll ask you a few questions if time permits. Just do the condensed one, because we are running on a schedule.
I'm June. I'm
Right here. I'm Andy.
So for our topic, we focused on the risk of stroke after brain surgery. So we came up with a fibrin antibody lipid nanoparticle infused hydrogel matrix to be placed into a resection after brain surgery. It acts as a more proactive treatment rather than a reactive treatment like most treatments for stroke are now.
Place the hydrogel in the resection directly after brain surgery, and the lipid nanoparticles would diffuse out and dissolve any blood clots that are not necessarily. But we would use enough fibrinogen antibodies so that there wouldn't be clots, but the fiber level in the body would still be at 6.
So in terms of our methodology, we ran 4 different Python simulations and 2 different diffusion simulations. So with the Python simulations, we trained it on a data set, and with the diffusion simulations, we just had more explorations and previous research.
And in terms of results, we were able to determine the optimal structure of our hydrogel matrix. And with that being our lipid nanoparticle size, as well as the optimal pore radius and the cross-link density. And we also did determine that 50.8% of the lipid nanoparticles successfully crossed the blood-brain barrier, as well as 17.56% actually reaching the targeted clot size.
So in conclusion, we provide a great proof of concept for a new therapeutic regimen from rather than being reactive to proactive, where we can have these strokes patients not have to worry about the constant risk of strokes, but rather we can focus on having patients focus on healing rather than worrying. And with this, we provide a new concept and statistical validation for that.
All right, I'll just ask the same question for all of our groups, but if there's one takeaway from this project that you're going to have moving forward into your later years at university, what would that be?
probably being able to read the scripture. Like, we had those like journal club days, and like I really wasn't wanting to spend the time to read through those, but I feel like being able to like learn how to do it and like work myself through those really like tough to read articles like will help me a lot.
Communicating and speaking up, and just collaborating with each other.
I think for me, the modeling aspect is very important. I think from going from data to actual graphs, I think that's something I'll carry with me the rest of my college career.
I think for me, my biggest takeaway is to find a team that like you have like a bit like really good team chemistry with. Fortunately enough, the four of us did have pretty good synergy, and we did complement each other's weaknesses, which I think really helped in the long term for our projects.
All right, guys. Thank you so much for talking.
Yeah, thank you for your time.
All right, let's go meet with another group.
Are you guys available to be on the live stream? Oh, yeah. Yeah, so feel free to introduce yourselves to the camera, maybe use your major, or if you already have one selected, and then feel free to give us a condensed pitch of what you guys made.
So we were Team 7. I am Lucas Cavino, an electrical engineer here at Ohio State.
I'm Swapman Joker. I'm a CSE major here at Ohio State.
I'm Cameron Burrell. I'm a mechanical engineer here at Ohio State. So here we are presenting the solar panel, an alternative cleaning solution to homeowners' solar panels. So right now, there's a gap in the market. We have solar panels that require cleaning every 6 months, and there's only either manual cleaning or robotic cleaning, which is significantly expensive compared to the price of a normal everyday solar panel. With that, we created a prototype that uses PTFE wind strips. So as it spins, it resuspends the dust particles into the air and moves it around. It's a low cost, it's low cleaning, and it's highly effective. Would you like to talk about some of the data and testing?
Yeah, absolutely. So here's going to be our simulation of the static sprint. So this tested if it could last about 7.5 years, and you can see in the red that it did, and then a little sliver of blue that didn't last. That would be something that we look forward to in the future. Here, that dark green line, that's going to be our with the prototype, and the light blue is going to be without. You can see pretty consistently that we had a higher efficiency and power output with our prototype than without. And then this is going to be the soiling tool. Our prototype consistently removed more soiling than without. As for optimization, we were able to get about 84% coverage on the panel, and it only costs about 1.82% of the total panel. Well, now take it away with the conclusions.
So our wind-based cleaning solutions uses cheap and durable materials to ensure low maintenance and no water and electricity is used excessively. In fact, it's not used at all, which ensures high sustainability, and the fact that it's durable ensures that no cleaning risks need to occur, which overall means homeowners have a passive way to clean off soiling matter using our wind-based cleaning system. Future work could look into different materials in the wind strips that are more flexible to ensure greater durability and more soiling matter is removed. And the geometry and the lengths of the strips can also be modified, such as using a 4-prong design versus our current 2-prong design to ensure more soiling matter can also be removed.
So I'll ask you guys just one question, same question I'm asking all the groups. What's one skill, either highly technical or more general, that you think you've taken away from this project and will continue to apply for future years here at
Yeah, of course. So when given a topic of like sustainability, it's such a broad topic. It feels like it could be so big. The skill we learned was kind of finding something that we can make an impact in, bringing that such a large idea down into something that's more capable for our group. And I think we did do that with our prototyping design we made. And I think, do you have one?
No, I totally agree. Taking a large scope and bringing it down to a specific niche that we wanted to research. And also a lot of the backing up everything we've had, sources is super important, making sure that you have the proper information and studies to back up what you want to say.
Well, like they both mentioned, bringing down such a large topic as sustainability into something as simple as improving solar panel cleaning is probably a skill that we gained, and also actually doing research, looking at the resources, creating the conference paper, and also our poster is a skill we'll definitely be using.
Thank you guys so much for joining us in the live. Thank you very much. I'll try to find one more group that looks like people are winding down until the final awards presentation. All right, feel free to introduce yourselves, what your intended majors are, if you have them, and then give us a condensed spiel of what your project is.
So I'm Matthew, I'm a civil engineering major.
I'm Elias, I'm a materials science and engineering major.
So pretty much our project looked at fertilizer and activated carbon filtration. So farmers utilize fertilizer on their crops, and this is a big concern because when it rains, it washes off the fields and into streams, which can cause harmful algal blooms. These blooms can cause hypoxic zones, which deplete oxygen from areas, killing aquatic life, and it can cause toxins to be released in water, and what this means you can drink that water, causing death. So it's very important that we extract these algal blooms before they cause effects. So our main goal was to convert the collection of algae into fertilizer.
This was our initial design, and then we ended up converting it into a cylindrical design here. Some of our results, so what we did to test it was we substituted food coloring as algal toxins, and then tried to see if our activated carbon filter could pull those supplemented algal toxins out of the water, as well as we dyed a paper towel as a sample algae proxy, and then saw if we could pour water over that paper towel and then through the filter and remove the coloration from that paper towel to show that we could remove things from algae itself and create a clean, sustainable fertilizer. From our testing, we used RGB color codes of our images, and higher RGB color codes represent lighter color. And so we were able to see a significant increase for our paper towel or algal proxy, and from that we saw that we have great promise in a longer time test of actually removing the toxins from the algae and creating not just good fertilizer but also clean water from the filter. And this is our actual prototype model here. We have a stir bar that goes inside and actually mixes the algal samples, and then the activated carbon filter sits right inside here. So this is our project.
One question that I've been asking all the groups, what's one skill, either highly technical or just like a general skill that you've picked up on, that you think will carry on to your other classes, or even into your career after you graduate?
So one thing that I heavily worked on was definitely designing the prototype on Onshape. So I was considering like tolerances and other things. And I feel like that's a very important skill to learn, especially as a civil engineer, because working in the consulting firm, we like to make drawings for architects, and those drawings are then used to execute how to construct buildings. So learning how to use Onshape and create drawings is definitely essential skills for learning.
For me, the skill that I'm going to take away from this is the research aspect of the project. Since it was so open-ended, we didn't really have an idea of where we wanted to go. So turning research into an actual product, like working as a team like that, was really impactful for me. And I think it will carry over to the rest of my classes because I'll be able to take my learning in those classes and actually apply it like we did here, taking our research and applying it to our algae field.
Hey, thank you guys so much for choosing me on the live stream.
Of course.
I think we might have one more time for just one more group before we have to head over to the presentation. Would you guys like to be on the live stream? Yeah. So feel free to say your names to the camera and your intended majors if you have them, and then just give us a spiel of what your project is.
All right. Hi, I'm Krishna. I am pre-biomedical engineering currently, and I'm Kate. I'm a chemical engineer. I'm Joyce, and I'm a biomedical engineering major. I'm Spencer, and I'm a chemical engineer. So what our device is a ovarian cancer detection test, a pregnancy test, and this will be conducted through urinalysis. And we want it to be at home, accessible, and affordable for users to use. Yeah, so it's gonna follow like a pregnancy test sort of deal where we're gonna look at 3 different biomarkers, and in the different tests we're gonna be testing for different like test lines and looking at different concentrations to see if it's gonna actually reach the amount that we need at the test lines for the latex beads to be able to become recognizable. And then yeah, so we found from our results that just using the latex beads was not sufficient enough. So we turned towards an additional step called enzyme amplification. So essentially, after the urine has passed through that test strip and the biomarkers have binded to whatever they need to, specifically the latex beads and the conjugates, an additional solution
using tetramethylbenzidine and hydrogen peroxide would be run through the test strip, which would allow an embedded enzyme called horseradish peroxidase to actually amplify that signal up to 1,000 times. And so, as you can see from those graphs, without the enzyme amplification, the healthy, early, and not pictured on here, but the mid and late stages were not able to reach that detection limit by almost a factor of 1,000. However, with the enzyme amplification, in early stages, we saw that the biomarker concentrations were able to reach that detection threshold needed to create that color-changing sort of result. And it's also important to note with the healthy cases, even with the enzyme amplification, that the biomarker concentrations were not sufficient enough to actually reach that detection threshold, which would basically ensure that we're trying to minimize the false positives and false negatives results of our testing device.
Along with some of the success that my colleague Joyce talked about, we also conducted a material analysis and evaluated each of the materials that we would use with FDA standards, and we found that all of them would be safe for human use. Additionally, we conducted a cost analysis and found that our device would cost approximately $28, ideally being sold for under $30 in a lot of large retail chains. However, during our research, we ran into some pretty major limitations. We were incapable of conducting any lab testing in a lab setting, and additionally, when we were creating our MATLAB graphs, we had to take the average discrete values from literature for the concentrations of our biomarkers, rather than if you were to have a real sample, the concentrations would vary rather significantly. In the future, we would like to continually work with researchers who are capable of conducting this research in a lab setting. And then if this research were to be done, this product would be iterated and perfected, working with biotech companies to create this product, push it out into the market, and ideally help women around the world. Thank you.
One question that I've been asking all groups, what's one skill that you guys have taken away, either highly technical or maybe something like group work, that you intend on applying in future courses or even in your careers after you graduate?
I think the main thing that I learned from this project is adaptability, being able to iterate on something and always looking for new methods to make our device better, make it more accessible, more useful, and overall help people better.
Mine would probably be technical writing or being able to understand research, specifically ones that are a lot more sophisticated than what I'm used to.
For me, the importance of communicating with professionals in the field. We were able to talk with 3 different doctors. One of here is at the James, one works here at Ohio State, and then one of them works at Virginia Commonwealth University. Just building the repertoire of professionals that I've talked to and working on overall communication with professionals was super enlightening to me and would like to be super helpful in my professional career.
Yeah, I would say my biggest thing would probably be perseverance. Specifically with our project, we saw that with the enzyme amplification, we had actually discovered that around a week before final testing because our results were showing that the latex beads alone were not sufficient enough. So just understanding that engineering is a truly iterative process and just learning the value of not giving up.
Right, guys. Thank you so much for speaking with us and being on the live stream.
Of course. Thank you.
I think that's going to wrap it up for the 1282.02 projects. At 12:30, we will have the awards presentation, so for those of you watching at home, be sure to check back in with us around that time. Thank you so much for being here with us, and we'll talk to you soon.
Hello, how are you guys?
Hey everyone, hope you're enjoying the EEG showcase.
Yeah,
It's all
hope you
going
are.
well. Thanks for coming.
We can pause now.